And this is number 33 from section 10.3, or 10.2, pardon me, 10.2. And read the problem here. But again, these aren't too bad. You know, the sketching was maybe a little bit of a hassle, but not that bad. It says a particle moves in the plane with position vector cosine 3t sine 2t. Find the velocity and acceleration vectors and determine the path of the particle. So again, this was my position vector. So we just take the derivative, and this is just another way of notating it. I'm just going to take the derivative of this vector to get the velocity vector. And that means I'm going to take the derivative of each component. So the derivative of cosine 3t is this, negative 3 sine 3t. And the derivative of sine 2t is this, 2 cosine 2t. Straightforward. Then if we want the acceleration vector, we just take the derivative of the velocity vector or each component. And the derivative of negative 3 sine 3t is just negative 9. Don't forget the chain rule again. Have the chain rule here and the chain rule here. Don't forget that. And the derivative of 2 cosine 2t is going to be 2 times 2, which is 4. The derivative of cosine is negative sine 2t. So that should be pretty easy. And then we wanted to trace it, or it said determine the path of the particle. So I just used my calculator and I just got something like this, and I used the trace function, and so it's easy to see. I just kind of traced my t-step from 0 to pi, so I start here and I go in this direction, and this is the path from 0 to pi, and then I put from pi to 2 pi in green, so it's a little bit easier to see, and then it goes from here all the way around like this and ends up there, and that's one complete, I guess, round between 0 and 2 pi. So from 0 to 2 pi we start at the beginning, and it just continues the same. So it goes like that and then like that. Okay? So color coding it makes it a little bit easier, again, as I go from 0. And you could use, like I said, you would graph the position function. So I just graph the position function, or the position vector, in parametric mode. So this went in, y1, y, or x1, y1. All right. And then I think my t-step was I guess 0.1. And I just x and y min. I didn't put the table here, but I think I just used 2 plus or minus 2 for each of these. So it'll be a little bit easier to, so you can actually see it. So I just used the window was, x goes from negative 2 to 2, and y was negative 2 to 2. So that's my window. And then, like I said, I used a t-step of, I think, 0.1. And I went from 0 to 2 pi. So t goes from 0 to 2 pi. And that took me all the way around. So, like I said, you can check that on your calculator. We'll start here. Again, 0 to pi. And then from pi to 2 pi, it looks like this. Okay? So that was pretty straightforward. Not too bad. And then number 35. This is a little bit smaller because I did this before, so then I started trying the color thing. Okay, sorry, I got it kind of on a line here, so this is a little maybe hard to see. Don't worry about that, that's just my line for my paper. But 35, a particle moves in the plane so that the position at any time t greater than 0 is given by x equals 4. Sine 4t cosine t and y equals sine 2t. Find the velocity and the speed of the particle when t equals 5 pi over 4. So we just had to take the derivative of the position vector. So if I took the derivative of the x component, this was the x and this is the y, I separated them out because we were given xy. So I took the derivative and I used the product rule. So first times the derivative of the second, derivative of the cosine is negative sine. Okay, plus the second, which is the cosine, times the derivative of the first, which is 4 cosine, 4t. And the dy was just 2 cosine 2t. So this was my velocity vector. And then we wanted to find the velocity when t was 5 pi over 4. So I just substituted 5 pi over 4 for t. So every time I see a t, I put a 5 pi over 4. So this is 4 times 5, which would be 20 pi over 4. 5 pi over 4, 20 pi over 4, 5 pi over 4, and then 2 times. And then 2 times, then 2 times 5 pi over 4 would be 10 pi over 4. And then, you could trace these all the way around or check them on the unit circle, and this ended up being this is basically 20 over, that's 5 pi. And this we just do with our unit circle, and this is going to be negative square root of 2 over 2. And this was 5 pi, and this was going to be square root of 2 over 2, and this is just 5/2 pi. And then if you work this out, the cosine of 5 pi was -1, because it's the same thing as pi. And the sine of 5 pi was 0. Okay. Because it's multiples of pi. And these are plus and minus 1 multiples of pi. So we have 4 times -1 times negative square root of 2 over 2, which is just 2 times the square root of 2. And this was 0, because that was a 0 factor. So that's all we had here. And over here, the cosine of 5 pi over 2 is 0, so we just had 0. So this is my velocity vector. Now remember, the speed is just the magnitude of the velocity vector. And there won't be any signs because it's always going to be the square root of a squared plus b squared to be positive. So, or x as a function t, y as a function t squared. So same thing. So we just find the magnitude of this vector, which is the x component, the square root of the x component squared plus the y component squared. So that was just going to be square root of 2. And that was just going to be 4. Well, it ended up being this, because if we square this whole thing, it just ends up being 2 times the square root of 4. I guess if you worked it out, you would have 4 and then 8. 4 times 2 is 8, and then you end up simplifying it the same thing. So it's either way, you're going to get that. Okay? Now we want to find the position. Now we want to... That was the A part, okay, finding the velocity and the speed of the vector. So this is all the A part. Now the B part was draw the path of the particle and show the velocity vector at t equals 5 pi over 4. So we had to find the position at 5 pi over 4. So I put this into the position vector. If I put this in the position vector, okay, or the coordinate actually, I can find the coordinate. And the coordinate was just going to be this, because they're in component form, so the same thing. Position and the component would be the same thing, so the vector. We want to find the position, so we just put this in the ordered pair. Sine of 4 pi cosine sine of 4t, cosine t, sine of 2t, and that's at 5 pi over 4, so we put that in for t, and we end up again with 20 pi over 4, 5 pi over 4, 10 pi over 4, and then when we work this out, we end up with the point 0, because this is going to be 0, and this would be 1. Okay, the sine of 5 pi over 2. Okay, so my point I was at, my position at 5 pi over 4 was 0, 1, 0, 1. Now this is the path. I put this in my calculator, and I did the same thing. As I go from 0 to pi, I start over here, I go down like this, and notice I got my arrow, so that means I don't go this way. This tells me I got to go this way. So it's kind of funny. So you start over here, and instead of crossing, you stop here, and then you go around this way and that way. So that was my movement, okay, between 0 and pi. And then from pi to 2 pi, I go over this, like this, follow this path, but I don't go this way. See, my arrows are hitting each other, so I would have to go this way. So by writing the arrows, it helps me remember. So again, I'm starting this way, follow the arrows around. Nope, it's not like that. It goes like this, stop, and like this, and ends there at pi. And then from pi to 2 pi, it goes around like this, and this goes around like this. Okay? Now, at 0, 1, at 5 pi over 4, again, if I look at my path, this was the first. And you see, each of these would be a fourth of pi, because this is a quarter pi, quarter pi, quarter pi, quarter pi, gets me to pi. So 5 pi over 4, this would be another quarter pi. And you could check that out. You could trace that on your calculator, and then you could just put 5 pi over 4, and this is where you are. So this is my position, so that makes sense. So my position at 5 pi over 4 was 0, 1. And so this is the vector. It's going in this direction because I'm going to go around this way, so it's headed in that direction. And this was the speed or the magnitude. So this was actually an indicator of the velocity vector, all right, at 5 pi over 4. And where was the direction? They asked what the direction was, and it's to the right. Okay, so that's pretty much all you had to do. Okay, so that's number 35. So if that helps.